zeros to start with. They were saying factor completely given something was a zero. Factor completely given you had a specific term of the equation. Today, you're going to be given the equation without knowing any zeros to start with. So this is going to be a little different, but there's a real nice, easy pattern to this. For example, if I wanted to find possible zeros, I'm going to find all the possible zeros of, oops, let's move this out of the way for right now. I want to find all the rational zeros of the following function. I have x cubed plus 2x squared minus 11x minus 12. And if I'm going to find all of my zeros, that means I have to factor it all the way out to get my zeros. Well, if I look at this right now, I have a 4-term polynomial. And when I have 4 terms of polynomial, I used to sit there and say, hey, can I factor it by grouping real quick? Just by looking at it, I know that I'm not going to be able to factor this by grouping. So I need another method. Here's where this rational zero theorem comes into play. Yesterday, I told you something was a zero, and you used that to find the other ones. Well, now you have to figure out the zero to start with. So there's a pattern to this. Here's what you do. You take all the factors of your constant divided by all the factors of the leading term coefficient, and you put a plus and minus in front of it. So in this example, what is my constant? The 12. So that means I'm looking for my factors of 12 divided by, what's my leading term coefficient? 1.
The leading term is x cubed.
Yeah, it'll always be the highest degree. Sometimes you have to move things around, but it'll always be the highest degree. Okay. Now, that means I have to list out my factors of 12. What are they? So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And what do I have to divide each of those by? 1. I know it's kind of not really necessary to show that I'm divided by 1, but not always will we have a leading term coefficient. That's 1. I'm just getting you guys to have it. So according to my calculations here, how many possible zeros can there be for this function?
6.
Count again. 12. Plus or minus. Okay? So we have 12 total possible zeros to work with here. Yes, sir?
We're going 1, 2, 3, 4.
Factors of 12. 1 times 12, 2 times 6, 3 times 4. Those are what the factors of 12 are. That's where that came from. Okay? Yeah. What's that? No, they're rational. Irrationals are I, square root of 2, things like that. Okay. So here's what we do. This didn't work on the clean thing. We have f of x was x cubed plus 2x squared minus 11x plus 12. And all these zeros are plus or minus 1. Okay, I'll change that. Thank you. Where am I? 4,
6, 11, 12.
Okay. Now comes the fun part. Fun. Did you know math was fun? In this case now, I have to figure out where my zeros are. So, pick 1 to start with. 1. And you're going to synthetically divide to find your zeros. Start with 1.
Wait, is there a faster way to do it than guess and check?
You're going to tell us how to do this faster.
This is the fastest way to do this. What I need you guys to understand here, what happens when you find a zero when you're synthetically dividing? that means you have 0 at the end, but what happens to the degree of the polynomial? It drops down. This is starting with a cube, correct? I can't factor it the way it sits, but if I get down to a quadratic, could I probably factor that quickly? That's what this is allowing you to be able to do. This is the fastest way to do this. This is one of the easier ways to factor, and it works for any types of factoring. Take your coefficients, 1, 2, -11, and -12, and then walk through your synthetic division. Drop the first term, multiply, add, multiply, add, multiply, and add. Was 1 a 0? No. Try -1. 1, -1, 1, -1, -12, 12, and 0. Is -1 a 0? Yes. I'm going to circle it so I know it's a 0. Did I end in a 0? Whenever you end in a 0, that means whatever you synthetically divided by was a 0. Okay?
So do you just stop once you get 3 zeros?
Well, you can, or you can keep going and keep using synthetic division, or isn't this the same as x squared plus x minus 12? Can you factor that? What do you get? What are your terms? You guys should know that.
-4 and 3.
Flip it.
3 and negative,
There you go.
whatever.
That factors out to be that then, right? What are your other two zeros?
-4.
So your zeros are -1, -4, and 3. Synthetic division, by using those rational zeros, by figuring out which ones it possibly could be, brings it down a degree and allows you to find the other ones quicker. Because you wind up dropping the degree and into something you should be able to factor.
What about 2 of 6? We haven't tried
We don't have to. We're done. We found all 3 zeros.
There's only 3 or something?
Because I'm saying third power, it's just 3.
Oh.
Remember, since it's a third degree polynomial, I can have up to 3 possible zeros.
I didn't know that.
Yep. Okay? So as we go through these things, remember, as soon as you find a 0, circle it, that way you know it's there. And then see if it drops a degree where you can continue to work through it. Yeah?
So you all your links continue to work for after you get like x squared plus x minus 12?
Sometimes we have to use a quadratic formula. It might not be factorable, you might have to use a quadratic formula. But it's getting you into something that you can factor quicker. Because when you're using the synthetic stuff, I'm not going to be able to get, if I can't factor it, that's not going to work to show me a 0. Because the quadratic formula sometimes works in radical form. So if you get down to a quadratic that you cannot factor, use a quadratic formula and you'll get your other terms. Okay? You guys all right? Let's try another one. Again, I start by writing out the equation. I have 2x cubed minus 5x squared minus 14x plus 8. Which means the first thing I have to do is list out all of my possible zeros. Which means I take all the possible factors of my constant, which is 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And I divide that by all the possible coefficients of my, or not coefficients, of my leading term coefficient, the factors. What are the factors of 2? 1 and 2. So I divide them all by 1. And then I have to divide them all by 2. And you will see something that happens. I have taken all of my possible zeros. I've listed them out. As of right now, all my factors of my constant in the end, 1, 2, 4, and 8. All of my factors of my leading term coefficient are 1 and 2. And as I listed these through, do you happen to notice something? They're all the same except for 1/2, right? What's 2 divided by 2? Didn't I already account for it in the beginning?
Yeah.
So I don't have to worry about it. What's 4 over 2?
2.
I've already accounted for it. What's 8 over 2?
4.
I've already accounted for it.
Now
That will happen. That will happen.
3 of them will be knocked out.
What's that?
Did they just like 3 of them will be knocked out, or did it just coincidentally with 3?
It's coincidental because it will happen when you're looking at fractions, depending upon what your leading term coefficient is and what your constant is. You could wind up with a fraction that's the same as an earlier problem. Okay? Yeah.
I'm just confused on why it's 1 and 2 instead of just 2. For the what we divide them.
What's 2 divided by 2?
1, but isn't it just 1? We wrote factor the leading term coefficient.
Yeah.
So that was 2.
2 times what is 2?
But why?
1
does it
and 2.
go-
1 is a factor.
But it doesn't say factor.
Yeah, I want the factors of the leading term coefficient, the factors of the constant. Okay?
I thought it was good. I just had leading instead.
Oh, okay, yeah, it's factors of, all right? Now, again, I'm going to start by synthetically dividing. So it looks like it's going to be awful. Start with 1. We have 2, -5, -14, and 8. Drop the 2. And that doesn't work. I know it's not going to be a 0 there, so I don't even have to add it together, do I? I know 1 won't work. Go to -1. Ooh.
Can you do this?
Is that you?
What?
The like,
Ooh.
that was you? Okay.
Again, is -1 a 0? -1 is a 0.
Maybe
Now, what am I left with?
Put a 2, put a 1
Yeah.
instead of a 2.
Yeah.
then
Oh,
put
thank
a
you.
dot.
Oh, so this is all screwed up then, isn't
Yeah,
it?
nothing as well.
Oh, sorry. Oh, boo.
Just skip negative.
Let's try that again. 2. Got my hopes up.
That was actually kind of
No, it's not gonna work.
No, it doesn't.
No,
It doesn't.
No, now it doesn't. Let's go to 2.
But negative 2. Darn, negative 2. I'm serious. It's a good idea.
Yeah, well, there's calculator, non-calculator, so you have to know how to do this. Yay! I know, synthetic division, as you get going through it does become very fast. And over the course of the next few days, that's all we're going to be doing is synthetic division, so you're going to get really good at synthetic division.
Slow down.
What's that?
So is there a way to do some calculator?
You can graph it and try and find zeros if you want, but there's going to be calculator, non-calculator. You have to do this by hand.
I thought that it's hard to
Okay. So now I know that -2 is a 0. And I want to show you guys what's happening here. Our original problem was 2x cubed minus 5x squared minus 14x plus 8. And as of right now, we know that -2 is a 0. If -2 is a 0, what's the term in parentheses? X plus 2. So what we've done is we've factored out an x plus 2, and now I'm left with now 2x squared minus 9x plus 4. By using synthetic division, this is what's left right now. This is just a straightforward trinomial. Whenever I get to the trinomial, with a quadratic, always check to see if you can factor it. What's 2 times 4? What times what is positive 8, but you add together to get negative 9. So can I factor that?
Yes.
So just factor it. So you're at 2x squared minus 8x minus 1x plus 4. And now you can factor it by grouping. Synthetic division gets you a jump start to find a 0, and then you wind up being able to factor something via grouping. Factor something from a quadratic. Take your GCF, you have 2x left than x minus 4. Take out the negative 1, and x minus 4. X minus 4. And after that, 2x minus 1, x minus 4. So you know you have a 0 at negative 2. I have a 0 at positive 1/2. And I have a 0 at positive 4. In essence, what we have done is we have factored this whole thing into these, oops, I was thinking the number 3 in my head, into these 3 terms.
So it's basically like working backwards from 56.
Yeah. Yep. Yes, sir.
So you're gonna have a term per like power of the leading like coefficient. So like if you had like 2x to the 5th, would you have 5 terms?
You have the possibility of having up to 5 terms. Some terms may be repeated.
Like would you have, would you have 5 parentheses or?
Yeah, but remember, it could be like x plus 2 quantity squared.
Oh.
It could be x plus 2, x plus 2. It can be a repeated 0. That does occur. All right, but yeah, in essence, yes. And that's what basically 6-7 says. The fundamental theorem of algebra is that whatever your degree is, you're going to have up to that many possible zeros. And we've been saying that all along, I just didn't call it that. Okay? This is how we set these things up. We're able to factor anything now this method. It's a very systematic starting point. And like you guys said, does it get worse? Well, yeah, because you can have higher degree powers. So let's look at something like that.
The 100 hours.
You don't want to do one like that, but if you want to, go for it. Let's look at this. And this is where we're getting into the 6.7 stuff. We're doing the exact same thing, but now I have a 5th degree polynomial, which means I can have up to 5 possible zeros. I've taken the brakes off, or the covers off, where my zeros may or may not be imaginary, but I won't know that until I get down to the quadratics. Using synthetic division will continually get me to that point. So in this case, we have x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. Which means the first thing I'm going to do is list out my possible zeros. What is my constant? What is my leading term coefficient? 1. Yes, ma'am. Yep. Yeah, throw the 0 in there. I was getting to that point, but thank you. That's very good. You remembered that. So the first thing I do is I list out my zeros, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Do I need to put those all over 1? If you want to, go ahead. But since your leading term coefficient is 1, it's not really that big of a deal. Okay? And like Brandon was just saying, now we start with our synthetic division. If you notice, I'm missing, like she said, we're missing that x to the 3rd power. When I'm using synthetic division, what do I put there then? 0. Good. And so away we go. 1, negative 2, 0, 8, negative 13, and 6. And I'm going to do this the same like I just did on the page earlier, is show you guys that we're starting with the x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. And we're going to factor this all the way down to all of its parts. What's the easiest one to start with as we're working through? 1. So let's use synthetic division again and start with 1. Drop the 1. and we're happy. You agree? So I know that 1 is a 0. If 1 is a 0, if 1 is my 0, what's my term that goes in parentheses? Good, x minus 1. So right now we factor this to x minus 1, and then I'm left with x to the 4th minus x cubed minus x squared plus 7x minus 6. That's what this line is telling us. Again, can I factor that the way it's sitting with the x to the 4th, x to the 3rd, x squared? Can I do any grouping or any of that mumbo jumbo? No. I can try, but I'm not going to be very happy. So, once again, what's your constant at the end? 6. What's your leading term coefficient? 1. Again, use synthetic division with all the possible zeros. It just so happens that the zeros, the possible zeros, are the same. Yeah?
They change the thing that it's -6? Like,
No, it doesn't, because then you'd have a positive 1 and a negative 6. A negative 1 and a positive 6. It doesn't change anything.
So you have to keep going to
Yeah. You just keep using synthetic division until you get to the quadratic, which you can factor. You use the exact same one. Because now, what I'm going to do here on this side, let me go back to this full page here. When I go back to here, we've already found this 0, right? So I'm just going to reuse this line, start over with another synthetic go, and aren't these all still the same possible zeros?
Yeah.
Okay, where do you want to start? Start at 1 again. Because what happened here, Leaf, is that you've already found 1 was a factor of this big junk.
So you have to find some more big jump.
Yeah. Start at 1 again. And 1 happens again. So now I have factored that x to the 4th term down to an x cubed term.
Also now we can keep it.
If it happens to be a sum or a difference of cubes, yeah, but in this case it won't, because what we have now is the following. We have an x minus 1. If my 0 is a positive 1, what's my term again in parentheses? X minus 1 again. And now my new polynomial here is x cubed minus x plus 6. I can't factor this. It's not a simple quadratic. Okay? If it's not a quadratic, what do I have to do again? Synthetic division again. Yes, sir.
Why isn't there an x squared in the last?
There's a 0.
Oh.
Okay? So again, I'm going back to this line. I start at 1 again. I'm going to take off the 0 because I'm not worried about it because it's already gone. I'm using my new equation, which started with an x cubed. It just so happens by dumb luck again that I have a 6 at the tail end. Don't I already have that full list of possible zeros going? Start at 1. It didn't work.
Wow.
Use -1 and continue. Try again with this same line. It didn't work. Go to 2. What's that?
I said I hate big chunks.
Oh, well, I'll make sure I only give you like 3 of them then.
Okay.
You're so far.
At least you're gonna give us 3 problems anyway.
I'm getting there. Yay! I found it. I know again, it's at -2.
Pretty sure I was a
It was. We're doing a great job. Way to go, team.
No soda
Is it no substress or vo substress?
team. No, most of it was like,
That's only on
Yeah.
Spain.
So we have an x minus 1, an x minus 1. If -2 is my 0, what is my term?
plus
Good. And x plus 2. And now what am I left with? X squared minus 2x plus 3. So, what times what is positive 3 that I can add together to get -2? That would be -3. What is it?
Anything negative
-3, -1 would give me -4.
Oh no. I don't know.
So, that means it's not factorable. What do you fall back on if you can't factor it by hand?
divide it.
Quadratic formula.
I know this.
So,
I waste every
Yeah,
tree.
this is
What am I
ridiculous.
doing?
These trees are beautiful and you're just
10 minutes already.
So
Approximately.
done.
pretty sure they just farm.
quadratic formula, opposite of b, plus or minus.
How
You
much
know,
do we have to pay for
the animals in
calculating
Amazon are
these
dying.
numbers?
Just think about that for a minute.
What's 4 minus 12?
Negative
-8.
eight. TI 97.
Oh.
So now I have an irrational answer, which is fine. How do you simplify the square root of -8?
You don't.
You do. How do you do that?
I wait no.
2i root 2. So this is 2 plus or minus 2i root 2 all over 2. What can I do to simplify that?
1 plus or minus
One
under
plus.
2.
Okay.
Only one I do.
So now we have all of our possible zeros. Our possible zeros are 1, 1, -2, and 1 plus or minus I root 2. That gives me 5 zeros, correct?
Yeah.
Here's 1, 2, 3, 4, 5. 5 possible zeros. It's repeated, but it's still considered a 0 because we were able to factor it out twice. Okay? And that's how this works. And yes, is this the longest, most drawn out, awful style that you're going to see? Of course, I showed you the worst it can get. A lot of times what happens with synthetic division and you're simplifying these through, it's a lot faster. It is so much faster. Fall back into your quadratics as soon as you get to a quadratic, guys.
We have no homework.
No, I'm going to give you some. Oh.
No, it's not all
It's
right.
harder
On
to make a problem than
6.6, page 363, 40 through 58 evens. And then for 6.7 on page 369, 22 and 24.
So are these all going to be this long?
No, the 6.6 stuff is you're going to list out, you'll start with your possible zeros and work your way through it. You'll probably come across them real fast. The 6.7 stuff, that's the one that might take a little bit longer because they're upper level polynomials. You're talking about things to the 4th and 5th degree. All right? If you can grab at least one chair on your way out, I would appreciate it.